Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7 students for today's session. As you can see on the screen, and you are well aware, my subject is physics. Just a minute. My subject is physics. We are in class 7th. Today we are going to start a new chapter, that is chapter number 8, probably the last chapter, electricity. And today we are in the session number 1. So it's a common word, electricity, which we use at home as a current, electric current, or simply a current. So before going to know about, already you have learned basics of electricity in the class 6th. But before going to know about the electricity, we should know about what is the history of electricity. Right? History means when it started, when and where it started, we have to know, right? When this is started, we have to know. So before going directly to our material or text, so if you recall, when you recall the history here, a Greek scientist called Thales is a Greek philosopher, Greek scientist, Thales, who used for the first time in the around 600 BC, before Christ. It's around now 2026 plus 600, 2626 years back. Right? The first time the word electricity is used by some observations. By observing something, they come to know that there is electricity. Then they studied further studies. After that, so many scientists involved till the date. They came to know there is a positive charge, there is a negative charge. There are two charges are there. And the negative charge will repel each other. Positive parts will attract each other. So many things they'll come to know. But before that, the first to study is Greek scientist Thales, who first observed in the form of when a stone, a blue colored stone, which is called as amber. It is amber, which is like amber is the word sky, in a color of sky, plus, right, fur. Fur is nothing but animal hair. Animal hair. When these two are rubbed with each other, for the first time, the Greek philosopher, when blue stone called amber rubbed with the fur, when they are rubbed with each other, they started attracting each other. Along with that, they also start attracting the dry leaves and small bit of papers. Means when the two bodies are rubbed, due to rubbing of bodies, both the bodies are acquiring opposite charges. That is observation first made in case of amber and fur. But later they tried with so many things: iron rod, glass rod, ebonite rod, cat skin, so many things, whatever available, they tried with the same. And finally they observed that because of the friction, because of the rubbing, two bodies will attain the opposite charges, what is named as positive charge and negative charge. Why they are attaining? Because when they are rubbing, the free electrons from one body, it moves to the other one. Due to the transfer of electrons, the body which is donating electron will get the positive charge. The body will receives the electrons will get the negative charge. Like that, the electric charges are identified as positive and negative in the beginning of the discovery by a great philosopher, Thales. Right? That is a basic history of this. When you move forward, Right. To our chapter here, when you move forward, you can see the basic history given here in the material also for us. What exactly we are going to learn in the electricity. The first word is static electricity. Just a minute. Static. Just pen is not working. Right. So, okay, let it be. Static electricity. Same thing. When a glass rod is rubbed with the silk cloth, right? When glass rod rubbed with the silk cloth, the transfer of electrons takes place from the glass rod to silk cloth. Since electrons are negatively charged, the glass rod loses some negative charge and gets charged positively. Similarly, the silk cloth contains more electrons than the number of protons, and so it contains the more negative charges than the positive charge. So the silk cloth is said to be charged negatively, and thus there are two types of charges, namely positive and negative. Clear? There are two types of charges are there. One is positive, other is negative. Finally, the charges are named as the substance which donates the electron, which transfers the electron will get the positive charge, and the body which receives the electron will get the negative charge. Right? Then, the unit of electric charge is coulomb. The charge generally denoted by Q, capital Q or small q. It is measured in units called coulomb, named after the scientist. Named after scientist Coulomb. It is denoted by C. The Coulomb is denoted by C. Right? The electric charge is denoted by capital Q. Then, properties of charges. So, what are the properties? When you are studying about the charges, we are saying there is a positive charge, negative charge, and all. What are the properties here? You can see the properties one by one. The following are the properties of the electric charges. There are two types of charges, namely positive and negative. Very important. Like charges repulse and unlike charges attracts each other. This is called law of electricity. Law of electrification or electricity. Right? That is, like charges repulse, unlike charges attracts. Just like in magnetism. Like poles repulse, north repulse, south repulse, but north and south attract. It is a universal truth, right? Which is called law of electricity. That is the first property. Like charges repulse and unlike charges attract each other. Then, on losing electrons, a neutral body acquires a positive charge. Bodies neutral means they contain same number of electrons and protons. When there is electron transfer takes place, that is a one charge, positive charge. On gaining the neutral charge, body acquires a negative charge, which receives the electron gets the negative. When no charge is supplied to or removed from the body, it is said to be electrically neutral. Right? The amount of positive charge present in the equal to the amount of negative charge present. In any body, when amount of positive and negative are same, then the body is said to be neutral, electrically neutral. But when they lose electron or gain electron, they'll get the either positive charge or negative charge. Right? Clear? Now, third point. The amount of charge present in a body, either positive or negative, is expressed in terms of integral number of the charge of electrons, which is considered the elementary entity of the electric charge. It is measured in numbers, how many coulombs it is. Right? Then, an electron and a proton both have the same magnitude of charge present on them. Means the magnitude is same, whether it is a positive or negative, the magnitude is same, but one difference is one is losing electron, other is gaining electron. The power, the strength is same. The charge on a body only tells about the excess of deficiency of electrons in the body, right? But does not refer to the total charge, either positive or negative, present in the body. Excess is there, you can transfer. If they are same, we cannot. When two bodies are rubbed together, and if one body is acquire positive charge by losing electron and other one, the second body acquires the negative charge equal magnitude by gaining the number of electrons as those lost by the first body. Electron lost by first body is equal to electron gained by the second body. Thus, the total energy of charge on both the bodies put together before and after electrification remains same. Thus, the charge is said to be conserved. This is known as law of conservation of charge. So there is no loss of charge. Only thing is one body is gaining the charge, other body is losing the charge, which is called law of conservation of charge, according to which charge can only transferred from one body to another and can be neither be created nor destroyed, just like energy, right? And last point, the charge supplied to the insulator. I'll tell what is the insulator to come across. Insulator which does not allow current to pass is not distributed over its entire surface of the remains stationary at the applied position on the insulator, while the charge supplied to the conductor is always resides on the outer surface of, not present inside the body. This is obvious because on insulator cannot conduct the charges and hence they tend to remain at the supplied position. When you are supplying the charge to insulator like wood, rubber, insulator does not allow electricity. So there is no one be spreading of a charge. Charge remains at some place where you are supplying. But in case of conductors, it always lies on the surface only. It won't go inside the body. Charge always lies on the surface, outer surface. For that, there is a experiments also proved, right? I'll explain in the later classes. Okay, so these all 7 points are the properties of charges. So first I identified the charges from the rubbing of the body, that is from friction, frictional electrification or static electricity is also called. Then they identified that there are two types of charges are there. Then they studied the properties of charges. How they get the positive charge, how get the negative charge, what is the magnitude of positive, magnitude of negative. So what happened when charge given to the insulator, or what happened when the charge given to the conductors. Everything is explained in the 7 points. So before going for the next part, we'll show you some video on the basics of the electricity, right?
Electricity. Have you ever wondered what electricity is and where it comes from? In this video, we are going to talk about electricity found in nature, called lightning, and man-made electricity like batteries, power plants, and more. Electricity found in nature is called lightning. Lightning is an electric current and is super hot, even hotter than the surface of the sun. Lightning occurs when small bits of ice bump into each other as they move around in a cloud together and create an electric charge. When the cloud fills up with these charges, it interacts with the opposite charges on the ground, kind of like the positive and negative sides of a battery. Lightning strikes, and you have an electric current. Electricity is all around us. Think about a day in your life and all the things you use electricity for. Would you be okay living without these things? But what exactly is electricity and how does it work? Are you ready for an introduction to electricity? Electricity is created when electrons move from one atom to another. When the electrons are moving, they produce something called an electric current. There are two types of electric currents, direct current and alternating current.
AC/DC.
Direct current is the power that comes from batteries. fuel cells, and solar cells. Batteries have a plus and minus sign on them. The plus sign stands for positive, and the minus sign stands for negative. The electric current in the batteries always flows in the same direction and in a loop from the positive to the negative side. Batteries power things like game controllers, flashlights, phones, even the TV remote we fight over. Fuel cells also work like batteries, except they don't need to be recharged. Fuel cells take chemicals like hydrogen and oxygen and put them together. When the two chemicals react to each other, or have a chemical reaction, electricity is created. Fuel cells can provide power for something as big as a utility power station to something as small as a laptop computer. There are even hydrogen-powered vehicles that use fuel cells. Some of these vehicles include forklifts, cars, boats, and buses. Have you seen solar cells on the roofs of various homes and buildings? Maybe you even have some on your own home. They look like black rectangles made of glass. The materials inside the boxes release electrons when light shines on them, which then creates an electric current. Can you guess where the light comes from that shines on these boxes? If you said the sun, you're absolutely right. Solar cells use the light from the sun to make electricity. There are some important words that have to do with electricity. These words are watts, or how much power a light is using.
Power.
Voltage, how much power is available for the light to use.
How much available?
And amps, how fast the electrons are traveling to the light bulb.
Ampere.
Shorter, longer, thicker, and thinner wires also affect how electricity travels. Shorter and thicker wires allow for better flow of electrons than thinner and longer wires. Now, let's learn about alternating current.
AC current.
Alternating current is an electric current that reverses directions many times a second.
We are using at
This
home.
power
Domestic
comes
use or
from
industrial.
power plants. The electricity travels through the power lines that you see along roadways and open fields. The electrons travel in a big loop from a power plant to the wires that are hooked up to your house, and then back to the power plant again. When you turn on a light in your home or plug something into an electrical outlet, the power flows from the power plant. But before it enters your home, it passes through something called a transformer.
Transformer.
Nope, not that kind of transformer. That would be really cool, though. Transformers are attached to the utility box or power poles near your home. The electric current flows from the transformer to the circuit breaker or fuse box in your home. That fuse box then routes the electric current to each of your outlets and switches. The transformer's job is to make sure that the right amount of power is going to your home. This is a very important job.
So many fuses are there.
If too much electric current flows all at once, it could blow a circuit and cause all the appliances in your home to stop working. And if too little current flows, it won't be enough to power all of your appliances. Power plants all over the country use different kinds of fuel to produce electricity. Thermal power plants use coal, biomass, petroleum, or natural gas to heat water into steam. That steam then powers a generator which produces electricity. Isn't that amazing that hot water can produce electricity? Nuclear power plants use fission, which means splitting atoms. Splitting the atoms creates energy, which produces heat, which also creates steam. Geothermal power plants use the heat located inside the earth to create the steam. And hydropower plants use wind and moving water to create the steam. Electricity can also be produced by magnets. Can you guess why? You already know that electricity is created when electrons move from one atom to another. But did you know that a magnetic field can move electrons? Power plants use giant magnets to create electricity in a generator. The generator has a coil of copper wire inside the magnets. Steam makes the generator spin, causing the electrons in the copper wire to flow through the power lines. Another type of electricity you are probably familiar with is called static electricity. Have you ever been shocked when you touched a doorknob after walking in socks across the carpet? That's static electricity. It happens when electrons move from one place to another, like from your hand to the doorknob. Electrons can move more easily in some objects than in others. And when certain materials rub against each other, like your socks and the carpet, they transfer electrons. Another example of static electricity is when a balloon is rubbed on your hair. You might have tried this trick before. It's fun. The balloon picks up extra electrons, which then attract your hair to the balloon. This causes a literal hair-raising experience. The name for any material or substance that allows electricity to flow through it is called a conductor. Conductors include metals like steel, copper, iron, gold, and silver. But water, animals, trees, and even people can be conductors too. That's why you should stay inside during a lightning storm. You do not want an electric current flowing through you. Insulators, on the other hand, are the opposite of conductors.
Does not allow electricity.
So, if conductors allow electricity to flow, then what do you think insulators do? They block or prevent the flow of electricity. Examples of insulators include plastic, glass, porcelain, and rubber. Most electrical wires are covered in a plastic or rubber coating. Can you guess why?
Right.
What do you think might happen if you touched a wire that wasn't wrapped in an insulator? If you said you could get shocked, you're absolutely right. It's important to never touch any wires that you see. You never know if they are live, which means that electric current is flowing through them. The plastic or rubber is used as insulators to prevent the electricity from traveling into other objects, like yourself. So, where did electricity come from? Electricity wasn't invented by anyone. It's a form of energy that occurs naturally. However, it is believed that the ancient Greeks first discovered static electricity in 600 BC. And in the 1930s, archaeologists discovered ancient batteries that may have been used at Roman sites. I wonder if those would power my controller. People have been doing experiments with electricity for years. You may have seen images of Benjamin Franklin, who was one of America's founding fathers, experimenting with electricity. A kite, a key, and a storm. Benjamin Franklin proved there was a connection between lightning and electricity. He was a pretty smart guy. There is much more to be learned about electricity. But what we do know is that without...
Okay, so lot of things explained here about electricity. Clear? So many things about electricity, different type of how we get electricity from thermal, from water, from garbage, from solar light. So many ways you can get the electricity which you are using domestically at home also. There is also electricity only which comes from the transformers or maybe inverter, maybe generator. All these are the sources of electricity where we cannot imagine our single minute also without electricity, because we need electricity for making the water heat and for charging the mobile phone, for cooking the food, and for making the food cool, water cool, everything, everywhere we have the requirement of electricity, which is produced by many sources, right? So that's what we discussed in the video after knowing about the properties of charges. So then also a very important thing we learned is about all the electrical appliances, all the electrical bodies which are influenced or categorized or classified into number one, conductors. What are the conductors? Suppose we have so many materials with you: iron, nickel, copper, silver, gold, and all. When you pass electricity to all the things, they allow the electricity. Conductors are those which allow electricity to pass through them, are called electric conductors. The second category is insulators. Just how we discussed in the video. Substances which does not allow electricity to pass through them, not allow, like rubber. Why you wear slippers while touching any electric appliance? Because slippers will not receive electricity, so we won't get the shock. They are the insulators. Plastic, wood, glass, all these are called insulators. That is second category. Third category also there actually. Semiconductors. Very important this is. They partially conduct electricity. They neither stop electricity, they neither send the electricity completely. Like silicon, germanium, the fourth group elements in periodic table. It's a very, very interesting topic. Silicon, germanium, and so on are the examples for the semiconductors which we are using for the, for example, if you see your dishes, your dish TV dish or television dish, so many electronic devices made with the semiconductors. The study of that semiconductors is only called electronics. The separate branch is there for semiconductors. But mainly we'll discuss about the materials which allows the current are called conductors, which does not allow the current are called insulators, which partially allows the current are called semiconductors, right? So these are the three classifications of the electric materials, right? Now, just to move one step ahead, methods of charging a body. Methods of charging a body, right? When a body is supplied with a charge, the process is called charging. How you charge the mobile? You can see the mobile charge, zero, it's a switch off. When you keep it for plug it and charging, we'll get the charging. Let us see the different ways of charging the body. One is charging by friction, rubbing. When a body is rubbed with over another due to friction, the transfer of electrons from one body to another takes place. Thus, one body acquires the negative and another acquires positive charge. That is first discovery. For example, when a glass rod rubbed with a silk cloth, transfer of electrons takes place from glass rod to silk cloth. Thus, silk cloth will get negative charge and glass rod will get the positive charge. That's the first method. Second, charging by conduction. Charging by conduction. Right. Consider a small metallic sphere. Right. Consider a small metallic sphere placed on a wooden stand. It's a metallic sphere. This is wooden table kept just like keeping in the wooden place as shown. Let us glass rod is rubbed with the silk cloth. We are rubbing with the silk cloth here. Right. When you are rubbing with the silk cloth, then brought into the contact with the metallic sphere placed on the wooden stand. The glass rod, when rubbed with the silk cloth, acquires a positive charge. when this positive charge glass rod is brought near contact with the metallic sphere, some of the electrons get transferred from metallic sphere to the glass rod. Thereby, the metallic sphere expired, acquired some positive charge. This process of electrical charges conducted by bringing it into the contact with another charged body is known as charging by conduction. By bringing charged body towards another neutral body, we can transfer. We are not rubbing here, just by touching. It's called charging by conduction. And third interesting one more is there. It's very interesting. Charging by induction. Even we are not touching also here. See, even you are not touching with one body with another. In the previous case, we touch with each other. But now, we are not even touching. See, there is a gap also there, but still through air particles surround this body, whatever the air particles are there, they carry the charge from here to here and they get the charges. That is called charging by induction. Charging by induction without direct touch. With the influence of first body, first charged body, second body also will get the charge, which is called charge by conduction, charge by friction, and charge by induction. These are the three different types of the methods to charge a body. Either you can charge by friction method, or you can charge by induction method, or you can charge by conduction method. Right? So, for today, what we will learn is, we learn about, first thing is about history of electricity, then what are the types of charges, and what are the properties of charges, and what way you can charge the bodies. That is three methods. So, in the next class, we'll have some more information about electricity. There's a lot to discuss. So, very, very huge topic to discuss, electricity. So, which will continue in the next class with the how to detect the charge. Whether charge is there or not. If there, what kind of charge? We can detect by some apparatus like gold leaf electroscope. Then we'll learn about the few important terminology of electricity. Right? What is electric current? What is electric potential? What is the potential difference? What are the applications, various applications? Everything you can learn in the coming 1 or 2 classes. We are going to complete the total chapter and course syllabus. This is some electric effects also, the chemical effect, electrolysis of water, that is applications. So many are there, metallurgical process. Okay. So that's all for today. Thank you all of you. Have a wonderful day. Thank you.